Let's begin with the basics. Before we dive into the wonders of the universe, it's important to understand the tiny building blocks that make up everything we see, touch, and even breathe. Every bit of matter around us is made from atoms. Whether it's the chair you're sitting on, the air you're breathing, or the device you're watching this on, atoms are everywhere, forming the foundation of all physical things. And inside every atom, there's a tiny trio that keeps everything together: protons, neutrons, and electrons. These three are the real stars of the atomic world, working together in perfect harmony to create the matter that makes up our universe. If an atom was a house, these three would be the family living inside. Each one has its own special role, just like family members who each contribute something unique to the household. Except instead of arguing about chores or what's for dinner, they're busy making sure the universe works smoothly. Their teamwork is what keeps everything stable and functioning, from the smallest grain of sand to the largest star. Protons, neutrons, and electrons are what we call subatomic particles. That means they're the parts that make up atoms, and they're so small that we can't see them with our eyes alone. That just means they're smaller than atoms. In fact, they're so tiny that even the most powerful microscopes struggle to show them clearly. In fact, you could fit billions of them on the tip of a pin and still have space for a spot of Vegemite. Imagine how small that is, so small that it's almost impossible to picture. These particles aren't just sitting around either. They have jobs, personalities, and even quirks. Each one moves in its own way, interacts differently, and plays a crucial part in the story of matter. They help decide what an element is, how it behaves, and even whether it plays nicely with others. The number and arrangement of these particles determine if something is gold, oxygen, or even water. So, let's take a closer look at each member of this microscopic family. We'll discover what makes each one special and how their unique traits shape the world around us. Get ready for a tour inside every atom and meet the team that holds the universe together. By understanding these tiny particles, we unlock the secrets of everything from chemistry to the cosmos itself. When you think about the tiniest building blocks of matter, you might imagine protons and neutrons as the ultimate small stuff, the end of the line, the smallest pieces that make up everything in the universe. But hold on, science always has another layer to reveal. Protons and neutrons themselves are actually made up of even smaller, more fundamental particles known as quarks. These are the true hidden players in the subatomic world, tucked away deep inside the nucleus of every atom. Think of it like Russian nesting dolls, where each layer you open reveals something even smaller inside. But instead of painted wooden dolls, you get a fascinating journey into the heart of matter, with each layer governed by the strange and wonderful rules of quantum physics. Quarks themselves come in 6 different types, or flavors, as physicists like to call them. But for the atoms that make up everything around us, the 2 most important flavors are the up quark and the down quark. These are the real stars of the show when it comes to ordinary matter. A proton, for example, is made of 2 up quarks and 1 down quark, all bound tightly together. This unique combination gives the proton its positive electric charge and helps define the identity of every atom's nucleus. Neutrons, on the other hand, flip the recipe. They're made of 2 down quarks and 1 up quark. This subtle difference is what makes neutrons electrically neutral, but just as essential for the stability of atoms. Now, electrons are a bit of an exception to this rule. Unlike protons and neutrons, electrons aren't made of quarks at all. They're what scientists call elementary particles, fundamental, indivisible, and truly unique. You can think of them as the independent loners of the subatomic world, orbiting the nucleus, but never mixing with the quark crowd. So, what keeps these quarks stuck together inside protons and neutrons? That's the job of the strong force, one of the 4 fundamental forces of nature. It acts like an incredibly powerful superglue, holding quarks so tightly that they can never escape on their own. This force is carried by particles called gluons, which constantly zip between quarks, binding them together in an unbreakable embrace. So the next time someone says, "You're made of atoms," you can confidently reply, "Actually, I'm made of quarks too." It's a fun fact that's sure to impress, or at least mystify your friends, and it gives you a glimpse into the incredible complexity hidden inside every bit of matter in the universe. Imagine the atom as a tiny solar system with its own unique structure and mysteries. Just like planets orbiting the sun, electrons zip around the center, creating a dynamic and fascinating world at a scale far smaller than we can see. At the very center of this miniature universe, you'll find the nucleus, a dense, compact core that acts as the command center of the atom. This is the atom's heart, and it's where protons and neutrons like to hang out. Close together, almost like best mates at a barbecue, huddled for warmth and stability. They form a tight-knit group, rarely venturing far from each other. The nucleus is super tiny compared to the rest of the atom. If the atom were a football stadium, the nucleus would be a marble at the center. Yet, despite its size, it holds almost all the atom's mass, making it incredibly important. Protons and neutrons are packed in tightly, so tightly they'd make sardines jealous. There's barely any space between them, and they're constantly jostling for position. They stick together, thanks to that strong force we mentioned before, the strong nuclear force. It's much stronger than the force pushing them apart, acting like an invisible superglue that keeps the nucleus from flying apart. Protons give the nucleus its positive charge, and the number of protons decides what element the atom will be. More protons mean a heavier, different element. Neutrons, on the other hand, don't have a charge at all. They're neutral, blending in quietly among the protons. They're the peacemakers, sitting quietly and keeping everything balanced. Without neutrons, the protons' positive charges would repel each other, and the nucleus would be unstable. Without this central cluster, atoms would fall apart faster than a sandcastle in a rainstorm. The nucleus is what keeps everything together, preventing chaos at the atomic level. So the nucleus is the glue, holding our world together, one atom at a time. It's the unsung hero at the heart of every atom, quietly ensuring the stability of everything we see and touch. While protons and neutrons are having their get-together in the nucleus, electrons are doing their own thing. They zoom around the nucleus in areas called shells, like energetic kids doing laps around a playground. These shells aren't solid walls. They're more like invisible pathways where electrons are likely to be found. Electrons never stop moving. If you tried to spot one, you'd only see a blur, like a seagull after your chips. Each shell can only hold a certain number of electrons. Once one shell is full, the next one starts to fill up, a bit like loading people onto a roller coaster. First car fills, then the next, and so on. Electrons may be tiny, but their energy and movement keep things interesting. Their dance decides how atoms join together to make everything from water to waffles. Alright, so every member of the atomic trio has its own personality, its charge. Protons are positive, electrons are negative, and neutrons are, well, neutral. Not too fussy, those neutrons. The positive charge of protons is balanced by the negative charge of electrons. In most atoms, the number of protons and electrons is exactly the same. That way, the whole atom is neutral, like a well-balanced seesaw. Neutrons don't have a charge. Their job is to stop the protons from flying apart. Without neutrons, the positive protons would repel each other like two magnets that just don't want to be friends. If you ever feel stuck in the middle, just remember the neutron. It's got no charge, but it's still essential, keeping the peace inside every atom. Atoms aren't always content with their electrons. Sometimes they gain an electron or lose one. When that happens, the atom becomes an ion. It's like when a friend joins or leaves your group. Suddenly, things feel very different. If an atom loses an electron, it has more protons than electrons. That makes it a positive ion. On the other hand, if it gains an electron, it becomes a negative ion. Sounds a bit confusing, but it's all about balancing that electrical seesaw. These ions are everywhere, honestly. They help electricity move in your body, power your phone battery, and even make your hair stand up on a dry day. So next time you rub a balloon on your jumper and stick it to the wall, thank the electrons for being so easygoing, and sometimes a little moody. What makes one atom different from another? It's all in the numbers. Change the number of protons and you've got a new element. Add a proton to a hydrogen atom and suddenly it's helium, ready to float a party balloon. Now if you change the number of electrons but keep the protons the same, the atom stays the same element but acts differently. It might become an ion or start reacting with other atoms in new ways, kind of like a chameleon changing colours. Neutrons are a bit sneaky. You can add or remove them and the atom becomes an isotope. Same element but with a little twist. Some isotopes are stable while others are radioactive. Great for smoke detectors, less fun for dinner parties. So atoms can be transformed just by swapping out their subatomic pieces. It's atomic level cosplay, really. Ever wondered why you can't walk through walls, apart from the obvious bruised nose? The reason is electrons. Those busy little negatives keep atoms from getting too close to each other. When two atoms come near, their electron clouds start to push against each other. The closer they get, the stronger the repulsion. It's like trying to push two magnets together the wrong way. They just won't have it. This electron repulsion is what gives things their shape and keeps your feet from sinking through the floor. It's also why bubbles are round and why you can't squash a grape flat without using some force. So next time you bump into a friend, remember, your atoms are just politely saying, "That's close enough, mate." It's amazing how much these three particles, protons, neutrons, and electrons, can do. They're tiny but mighty, building everything from skyscrapers to sunflowers, and even the spoon in your cereal. Their quirks and interactions decide what elements exist, how we get electricity, and why the world has such variety. Without them, the universe would just be an empty space. No chocolate, no dogs, not even a good cup of tea. Understanding these subatomic celebrities helps us see how connected everything really is. The next time you look at your hand, remember, you're looking at trillions of atoms, each with their own quirky trio inside. So, whether you're a young teen, a curious adult, or just someone who likes a good science story, remember, the universe's best team lives right under your nose, and on it, and in it.